of a curve at any point. So in this case, let's say we are given the straight line y is equal to 2x plus 3. So even if we are given this straight line, they say calculate the gradient. How do we calculate the gradient? They are saying, they are being specific and saying calculate the gradient from first principle. First principle. What do you know about first principle? You know, in first principle, you need f of x. Let's say our y is equal to is our f of x. And what do you need? You also need f of x plus h. That means f of x plus h. How do you find f of x plus h? That means they replaced where they saw x, they replaced with what? X plus h. That's what you are going to do. You are going to say 2 into x plus h plus 3. That simplifies to what? 2x plus 2h plus 3. So we have our f of x, we have our f of x plus h. Can we now use first principle? Yes. What do we do first? We are going to copy the formula. It's saying f prime x is what? The limit as h approaches 0 of f of x plus h minus f of x all over h. The limit as h approaches 0, since we haven't substituted 0 where we see h, we still copy the limit. So what is our x? F of x plus h is what? 2x plus 2h plus 3. Subtract. Remember, we are subtracting the whole f of x, so we must put it in brackets so that the negative sign can affect each and every number or variable in f of x. So in this case, what is our f of x? 2x plus 3 all over h. Then we have what? Limit as h approaches 0 of what? 2x plus 2h plus 3. Then negative times 2x is negative 2x. Then positive 3 times negative is negative 3 all over h. Then negative 2x and 2x cancels. Positive 3 and negative 3 cancels. You are left with what? Limit as h approaches 0 of what? 2h over h. Then h cancels h. You are left with what? The limit as h approaches 0 of what? Of 2. So you ask yourself, what is the limit as h approaches 0 of 2? Listen to me carefully. The limit as h approaches any number of a constant is that constant. What is our 2? Our 2 is a constant. Remember, if we try to plot our 2, let's say we have our y-axis and our x-axis. If we try to plot our 2, let's say here is 2. That means our graph is going to be a constant. That's what I mean about a constant. So constant is parallel to what? To the x-axis. When you are plotting a graph or our graph of 2, that means it's parallel to the x-axis, which is a constant. I hope you understood. So that means the limit as h approaches 0 of a constant is what? Is also 2, because a limit as h approaches any number of a constant is that constant. I hope you understand. So now we said from first principle we find what? The gradient, which is the first derivative. Let's see, we found 2 as our gradient. Let's go. We know that the gradient of a straight line is constant all the way. So that means even in our equation, remember our equation was being the form y is equal to mx plus c, where our c is our y-intercept, our m is our what? Is our gradient. So let's go check our equation. Our equation is saying y is equal to 2x plus 3. That means our 2 is our what? Is our gradient, which is our slope. Our 3 is our what? Is our y-intercept. So since our gradient here is 2, even from first principle we find 2, that means we are correct. We can conclude that from first principle you are going to find what? The gradient. But then remember, this is a straight line. That is why we find a constant number, because in a straight line we have the constant gradient. So let's try off a different graph. Let's say you have f of x being what? X squared. So what is going to be your f of x plus h? It's going to be x plus h squared. And remember, from grade 10 you have learned x plus h squared is x plus h into x plus h, which is what? Which is x squared plus 2xh plus h squared. So can we find the gradient of this graph f of x is equal to x squared from first principle? Yes. What are the requirements? We need f of x plus h. Did we calculate it? Yes. And f of x, we have it? Yes. So we are going to say f prime of x limit as h approaches 0 of what? F of x plus h minus f of x all over what? All over h. Limit as h approaches 0. What is our f of x plus h? Is x squared plus 2xh plus h squared minus what is our f of x? X squared all over what? H. Then what is next? We can see that our x squared cancels our negative x squared. Limit as h approaches 0, we are left with what? 2xh plus h squared all over h. When dealing with first principle, remember from grade 11 they taught you, from grade 10 or 9 they taught you that when you factorize you take out the highest common factor, but then in limits we have a different situation. We don't take out the highest common factor, we only take out a common factor of h that will cancel the h in the denominator. So in the numerator we just take out a common factor of a single h, because we only need a single h that will cancel the h in the denominator. So we are going to do what? Limit as h approaches 0 of h into what is left? We are left with 2x plus h all over what? H. Then h cancels h. We have what? The limit as h approaches 0 of what? 2x plus h. Can we simplify or factorize further? No. Can we substitute now? Yes, we can. We can write 0 where we see our h. That means we have what? We don't have to write the limit. We are going to write 2x plus 0, which is what? 2x. Oh, now, why is the gradient of this curve 2x, but the gradient of the straight line was what? Was 2. Why? What is the difference? Why does this one has a variable x? Why? That's a question that you must ask yourself. Then the answer is, as a mathematician, you know that a curve, the gradient of a curve is differs according to the points. So since, well, our f of x is a parabola, which is a curve, that means the gradient at x is equals to 2 and at x is equals to 1 is different. So that is why we have our gradient in terms of x. That means in this case, if they say calculate the gradient of this parabola at x is equal to minus 1, you are going to use your first principle, and after finding the formula, this thing, in simple terms, we can say this 2x, we can say is the formula of the gradient, is the formula of the gradient at any point in your curve. Yeah, we can say is the formula of the gradient at any point in your curve. So when they say, oh, at x is equals to -2, you just put -2 on your 2x. When you see your x, you write -2, then you find your gradient. That means, oh, now you see f prime x, which is the first derivative, is the gradient. That means when we have a curve and we find f prime x, which is the first derivative in terms of x, when they say find the gradient at x is equals to -1, we just write -1 where we see what? Where we see our x. That's when you'll be able to solve and find the equation of tangents. You will see when we go deeper into our calculus. So I think the lesson have to end here. Thank you for your time. Don't forget to like and subscribe.